everyone, nice to meet you. Today we have a nice problem to solve together. So let's begin. Our question for today is x cubed plus y cubed plus xy equals 2007. And prime factor decomposition of this number is 3 square multiplied by the prime number. This is a prime number. This is the 48 prime number. So our equation can be transformed like this. This is equivalent to x cubed plus y cubed plus y equal 3 cubed multiplied by 223. This quantity is a multiple of 3. This one also, so it's implied that x cubed plus y cubed equals 0 mod 3. And to continue, we need a lemma, this lemma to prove. We can prove this lemma using Fermat's little theorem, or we can use just a factorization method. So we have here x cubed minus x, can write it like this, and we can write it like this: minus 1 multiplied by x multiplied by x plus 1. And this is the product of 3 consecutive numbers, x minus 1, x, and x plus 1. These are 3 consecutive numbers. So the product is equals 0 mod 3. In every consecutive integer, we have the product equals 0 mod 3. And this implies that x3 equals x mod 3 for all x in Z. So here we must have x cubed equals x mod 3 and y cubed equals y mod 3. So we have the sum equals x plus y mod 3. Now let's return to our equation. This is our equation is equivalent to this quantity. We can write it like this: cubed minus 3xy multiplied by x plus y, and we add this term equals 3 cubed multiplied by 223. And now we must take a look to our new form. We have here x3 plus y3 equals 0 mod 3, and we have xy equals x plus y equals 0 mod 3, because this quantity is equal to 0 mod 3. So we have this quantity is a multiple of 3 cubed. This quantity is a multiple of 3. So this quantity is a multiple of 9, and this one is a multiple of 9, and this one is a multiple of 9. So this quantity must be a multiple of 1. So it's y equals 0 mod 3. Then we have two things. We have x plus y equals 0 mod 3, and we have x equals 0 mod 3 or y equals 0 mod 3. If one of these numbers is equal to 0 mod 3 and the sum is equal to 0, then the other is also. This implies that x equals 0 mod 3 equals y equals 0 mod 3. So the two variables x and y are multiples of 3, so we can put x equals 3a, y equals 3b. And the equation, the original one, this one, can be written like this. Then our equation can be written like this: a cubed plus the b cubed plus ab equals 223. And here we have three cases. We have the case A, B, both negative, and A, B, both positive, and A, positive, and B, negative. And because the problem is symmetric, we consider only this case. And if we find that AB is a solution, then BA is also a solution. So we take the first case, case 1. In this case, we have A negative and B negative. So we can put E prime equals minus B, which is positive, and we put B prime equals minus B, which is strictly positive. And then our equation became E prime B prime minus E prime cubed minus D prime cubed equals 223. We see immediately that this equation is impossible, because we can write it like this. And because P prime minus prime cubed plus P prime cubed is smaller than E prime B prime minus prime square plus B prime square, because E prime square is less than smaller than this, and B prime square is smaller than B prime cubed, and this is less than 0. And we have this quantity is equal to 223. This implies that 2023 is less than 0, which is impossible. So in this case, first case is impossible. Case 1 is impossible. So no solution in this case. We'll take the second case, case 2. In case 2, we have E positive and B positive. So our equation is E cubed plus B cubed plus AB equals, and then we can write this equation, or we can use this equation like it is. So we have is smaller than A cubed, because we can suppose that A is greater than B, because A and B are coprime. Because if there is a number that divides both A and B, then this number must divide this prime number. And this is impossible. You can prove it easily. So 223 is smaller than this A square, because we have A is greater than B, and this is equal to 2A cubed plus A square. And also we have is smaller than A cubed, and this term is less than A. It is less than A now, then plus A. So we must have A is between 5 and 6. Because if we give a 6, we have this quantity is greater than 2023. And if we give a 5, we have this quantity is less than 223. So if we give, if we put, we have here two sub cases. We have here A equals 5, or equals 6. We begin by 6. Then this implies that 6 cubed plus B cubed plus 6AB equals 23. And this, I've used my calculator, and this implied that b cubed plus 6b equals 7. And I see immediately that b equals 1 because 1 plus 6 equals 7. This implies that b equals 1. And then x, y equals 18, 3 is a solution, because remember we have x equals 3a and y equals 3b. So now we come to the other subcase where a equals 5. This implies that the 5 b cubed plus 5b equals 98, which is equal to 2 multiplied by 7 squared. And we can factor this quantity like this. So now we must have a look at this equality or this equation. We see that b, if b equals 0 mod 7 and b squared plus 5 equals 0 mod 7, this is impossible because we must have 5 because the second equation, this one, gives b squared equals 2 mod 7. And this contradicts this one. And this equation contradicts this equation. So we must have only one term which is divisible by 7. Then it must be divisible by 7 squared because the right-hand side has a factor 7 squared. And because this is the greater one, because we have b squared plus 5 is greater than b, then we must have 7 squared must divide b squared plus 5. And here we have two subcases. B squared plus 5 equals 7 squared. This implies that b squared equals 49 minus 5, which is equal 44, and this is impossible because 44 is not a perfect square. The other case equals 2 multiplied by 10 squared. This implies that b squared equals 98 minus 5, 93, and 93 is not a perfect square, and this is impossible as well. So case A equals 5 is impossible. And now we must go to the last case. Last case is when A is positive and B is negative. This is case 3. And here we have A is positive and B is negative. So we put B prime equals minus B, which is positive. And then our equation is a cubed minus b prime cubed minus a b prime equals 223. And we see immediately that this implies that a is greater than b prime. Otherwise, this quantity is negative. If we have, as I say otherwise, if this quantity is not true, then this will negative and this quantity is negative and it's impossible. So we must have a greater than b prime. We can write this quantity like this: cubed plus 3a minus b prime multiplied by b prime. And our equation here become a minus b prime cubed plus 3a minus b prime multiplied by ab prime minus ab prime equals 223. And our equation is equivalent to cubed plus ab prime factor. This is a common factor here and here. Then ab prime minus 1 equals 223. And so because E is greater than b prime, so we have is strictly greater than 0, is strictly positive. So this quantity is strictly greater than strictly positive. And then we can say that 3 minus 1 is greater than because here we have is greater than 1. So we have this plus p prime is less multiplied by AB is less than 2023, because this is a positive and this quantity is greater than 2a minus p prime. And then this implies that a minus p prime is less than 6, because 6 cubed plus 2 multiplied by 6 equals, I'll use my calculator, please wait, 6 cubed plus 2 multiplied by 6 equals 2028. So we must have is strictly smaller than 6. Because here we have 2028 is strictly greater than 223. Then we have the subcases, have subcases with a minus b prime equals 1, 2, 3, 4, and 5. I will solve some of them, not all of them, for a minus b prime equals 1. Then we get is implied. I'll show the equation. This is our equation. Then we must have 1 cubed plus ab prime multiplied by 3 minus 1 equals 2023. And this implies that ab primes equal 2 equals 222, and this implies that ab prime equals 1, 1, 1, and this is equals, this is divisible by 3 because the sum of the digit is 3, and it is equal to 3 multiplied by 111 divided by 3 equals 37. She's a prime number. And because we have a is greater than b prime, then we must have a equals 37. Simply a equals 37 and b prime equals 3. But this is not a solution because we have 37 minus 3 cubed minus 37 multiplied by 3 is greater than 2023. Now we'll take a minus b prime equals 2. This implies that 2 cubed plus AB, A in 2B, no, plus AB multiplied by 3 multiplied by 2 minus 1 equals, this implies that 5AB equals 2003 minus 8, which is equal to 250. And this implies that AB equals, I use my calculator, divided by 5 is 43. And because we have A is greater than B prime, this implies that A equals 43 and B equals 1. And this gives no solution because 43 cubed minus 1 cubed minus 43 is largely greater than 223. And we continue in this like this. We continue like this to prove, and we'll get that there is no solution in the case A positive and B negative. So the only solution, the unique solution is xy equals 18 and 3. Thank you for watching.